Welcome back to Drive and RPM. For the past 3 years, the entire narrative surrounding Tesla's future dominance has been tied to a single monolithic cylindrical metal can, the 4680 battery cell. Elon Musk took to the stage on Battery Day and promised the world that this in-house engineering marvel would slash production costs by over 50%, dramatically increase energy density, and secure Tesla's undisputed reign over the electric vehicle market for the next decade. It was a beautiful, compelling promise. But in the ruthless world of automotive mass manufacturing, physics, chemistry, and economics do not care about promises or presentation slides. The reality in April 2026 is brutally different. The in-house 4680 cell program has completely failed to deliver the massive cost breakthroughs that were theoretically projected. To understand why, we have to look at the forensic engineering of the DBE, or dry battery electrode process. Tesla tried to eliminate the wet, toxic slurry traditionally used to coat battery foils, aiming to use a dry powder instead. The theory was that this would save massive factory floor space and eliminate giant baking ovens. But the reality of trying to roll a dry mixture of active materials and PTFE binders onto a microscopic foil at high speeds, without the powder crumbling, flaking, or tearing the foil, has proven to be a manufacturing nightmare. Yield rates at Giga Texas struggled for years. The cells they did manage to produce simply did not have the energy density required to crush the competition. As a direct result, Tesla is currently facing an unprecedented margin crisis. Their automotive gross margins, which were once the envy of the global industry at a peak of 27% in 2021, have plummeted to roughly 15%. The Western giant is bleeding profitability, while Chinese behemoths like BYD are systematically crushing price barriers globally with their fully vertically integrated supply chains. Until now, Tesla relied on 4 main power battery suppliers globally: CATL, Panasonic, LG Energy Solution, and BYD itself. Yes, the irony is thick. Tesla had to buy the BYD Blade battery just to stay competitive in the European entry-level market. But the empire is not ready to fall. In a desperate and brilliant tactical maneuver this week, Tesla has officially added a 5th global supplier. They have tapped into a Chinese titan that the Western media rarely talks about, a company possessing a secret weapon that could change everything. A true 15-minute ultra-fast charging architecture. This is the story of how Tesla is deploying advanced Chinese engineering to fight the Chinese invasion. While the Western automotive press fixates almost exclusively on CATL and BYD, Sunwoda has quietly and aggressively become a dominant force in high-rate discharge and extreme fast charging technology. In April 2026, industry sources confirmed that Sunwoda has officially entered Tesla's global supply chain. Their cells are already being equipped in vehicles produced at Tesla's Shanghai Gigafactory, specifically destined for the export market. But why Sunwoda? Why add a 5th supplier when you already buy from the biggest names on Earth? The answer lies in the physics of time and consumer psychology. Recharging efficiency is the absolute final barrier to mass electric vehicle adoption. Consumers who are used to spending 3 minutes at a petrol station do not want to wait 45 minutes at a supercharger, especially during holiday road trips. Sunwoda recognized this early on. Before they built EV batteries, they mastered the chemistry of incredibly fast-charging lithium polymer cells for the world's most demanding smartphones and laptops. They took that microscopic knowledge and scaled it up to industrial proportions. They pivoted their entire multi-billion-dollar research and development budget towards obliterating charging times. They are not just building batteries. They are building advanced energy transfer pipelines. Tesla's partnership with Sunwoda is a surgical strike designed to achieve 2 critical objectives. First, to drive down base battery costs through aggressive supply chain diversification. By adding a hungry competitor to the mix, Tesla forces CATL and BYD to lower their prices to keep their contracts. Second, and most importantly, to integrate third-generation lithium iron phosphate, or LFP, materials that support face-melting charging speeds. Tesla realized a harsh truth. If they cannot win the cheap battery war against BYD by building the cells themselves in Texas, they will leverage the cutthroat competition within China to their advantage. They are arming themselves with Sunwoda's ultra-fast charging technology to ensure the Model 3 and Model Y remain the most practical, fastest charging mainstream EVs on the planet. To truly understand why Tesla chose Sunwoda over expanding their CATL orders, we must dive deep into the forensic engineering of what Sunwoda calls the Flash Battery 4.0 architecture, specifically the Xinxingqi 2.0 kA Extreme Charging Edition. This is not your standard, sluggish LFP cell. Traditional LFP cells are incredibly durable and safe, but they are notoriously slow to accept a high current charge due to their inherently high internal resistance. If you push too much power into them, they heat up rapidly, triggering the battery management system to throttle the charging speed to prevent a fire. Sunwoda's engineers went back to the atomic level to solve this. On the cathode material side, they did not just use standard lithium iron phosphate powder. They combined nanoscale and microscale LFP particles. Think of it like packing a jar. If you only use large rocks, there are massive gaps. If you mix rocks with sand, you create a dense, highly conductive matrix. They then took this matrix and coated it with a proprietary, highly conductive carbon layer network. Next, they paired this cathode with a low-resistance, high-conductivity ceramic-coated separator technology. From a structural and manufacturing standpoint, they abandoned traditional jelly roll cylindrical designs. They utilized an ultra-precision stacked cell process combined with a full-tab open or tablis batado design. In a normal battery, the energy has to travel through a tiny metal tab to exit the cell, creating a massive bottleneck and generating extreme heat. By making the entire edge of the foil act as the tab, the energy travel distance is reduced to almost zero. What does all this technical jargon mean in the real world? We have to look at the fundamental formula of thermodynamics: Joule heating. Heat equals current squared times resistance. To pump massive current into a battery without melting it, you must eradicate resistance. Sunwoda successfully reduced the internal resistance of the cell to an astonishing 0.36 milliohms. When internal resistance drops to this microscopic level, heat generation during fast charging plummets. This reduction in resistance cuts the temperature rise during ultra-fast charging by a massive 6 degrees Celsius compared to standard cells. This thermal headroom is what allows Sunwoda to pump an absurd amount of current into the battery. We are talking about a world's first, an ultra-fast charging battery product that increases the charging current to an unbelievable 1,400 amperes. When paired with a 1,000 volt or even an 800 volt high voltage system platform, this single cell architecture can support up to 1.4 megawatts of flash charging power. Let's translate 1.4 megawatts into actual driving reality for the consumer. At peak performance, this battery architecture can add over 150 kilometers of range in exactly 1 minute of charging. It can replenish 450 kilometers in just 5 minutes. And for the larger 268 ampere-hour LFP cells currently rolling off their automated lines, they have achieved a stable, repeatable, and safe fast charge from 10% to 80% state of charge in a flat 15 minutes. But the true genius of Sunwoda's engineering isn't just raw speed in a climate-controlled laboratory. It is survival and performance in extreme, punishing environments. One of the biggest, most valid criticisms of LFP chemistry in the Western world is that it effectively dies in the winter. Owners in places like Norway or the northern United States suffer massive range anxiety when the temperature drops below freezing. Sunwoda deployed a multi-level technology integration to defeat thermodynamics. They utilized a low-temperature-resistant, high-energy LFP cathode technology combined with a customized low-temperature superconductor electrolyte. In cold weather, traditional liquid electrolytes become viscous. Like molasses, the lithium ions struggled to swim through this thick fluid. When you try to fast charge a cold battery, the ions cannot insert themselves into the anode fast enough. They pile up on the surface, a process known as lithium plating. This permanently damages the battery and creates dangerous metallic dendrites. Sunwoda effectively altered the viscosity and conductivity of the electrolyte so that it remains highly fluid even when the battery is freezing. The result is an LFP cell that retains over 90% of its energy capacity, even at -20 degrees Celsius. They have completely solved the cold weather charging penalty that has plagued electric vehicles for a decade. Furthermore, their proprietary battery management system uses predictive AI models. It can detect the microscopic early signs of lithium plating within milliseconds, adjusting the current in real time to guide lithium ions safely into the graphite structure. It is an impenetrable fortress of energy storage, wrapped in an aerospace-grade thermal insulation package. The geopolitical and industrial irony of this alliance is absolutely staggering when you look at the macro picture. Tesla, the undisputed crown jewel of American automotive innovation, the company that forced the world to take electric vehicles seriously, is currently engaged in a brutal, margin-crushing price war with BYD. BYD manufactures its own cars, its own chips, its own motors, and its own batteries, giving them a vertical integration advantage that seems mathematically unbeatable by Western standards. Tesla tried to replicate this ultimate vertical integration with the 4680 cell. They wanted to own the entire stack, but they hit a massive wall of manufacturing scaling issues, material science bottlenecks, and immense capital drain. So, Elon Musk did what any pragmatic, ruthless general would do when facing superior numbers. He found a highly capable mercenary. Sunwoda's power battery division had been aggressively expanding its manufacturing footprint, investing heavily in research and development, and building massive economies of scale. By pulling Sunwoda into their global gigafactory supply chain, Tesla executes a brilliant piece of game theory. They instantly force CATL and BYD to sweat. More suppliers mean more competitive bidding, which will help Tesla claw back some vital margin on its highest single cost input. This is the empire striking back by exploiting the massive manufacturing overcapacity within China itself. The Chinese government aggressively subsidized the battery industry, leading to a surplus of highly advanced manufacturing capability. Tesla is essentially walking up to the buffet. They are taking the world's most advanced 15-minute ultra-fast charging LFP cells, developed entirely by Chinese engineers and funded by the Chinese industrial machine, and putting them into Western-designed cars to destroy Chinese automotive market share globally. It is an automotive Trojan horse. The partnership between Tesla and Sunwoda marks the definitive beginning of the megawatt charging era. It signals the death of the legacy automotive mindset. The psychological barrier of electric vehicle ownership has always been the anxiety of the charger waiting time. By integrating third-generation LFP materials capable of absorbing 1,400 amperes without degrading, without overheating, and without failing in the winter, Tesla is preparing to make the traditional gasoline station entirely obsolete. You pull up to an upgraded V4 supercharger, you plug in the cable, you walk inside to buy a coffee, and before that coffee even cools down to a drinkable temperature, your vehicle has safely ingested 450 kilometers of range. The 4680 Dream may be on life support, but Tesla's pragmatic, aggressive pivot to Sunwoda proves they are willing to adapt instantly to survive the EV bloodbath. They are not paralyzed by pride. The traditional automotive industry in Detroit, Stuttgart, and Tokyo needs to pay very close attention to this move. While European brands are still struggling to make their infotainment software work without crashing, and while American legacy brands are retreating back to hybrid vehicles, Tesla is quietly weaponizing the most aggressive, technologically advanced battery suppliers on Earth. The empire is not dying, it is not retreating, it is simply reloading with heavier, faster ammunition. Drive safe, and I will see you in the next deep dive.